Its duty is to prevent exhaust gases from backing up into the diverter valve and air pump in the event of an exhaust backfire or air pump drive belt failure. If the check valve fails, the diverter valve, air tube, and air pump will be suspect for damage also. One sign of an inoperative AIR system is if you fail to pass a vehicle emissions inspection. Since the AIR system helps lower exhaust emissions, a check valve or manifold failure will produce higher than normal levels of hydrocarbons and carbon monoxide gases. Sometimes, a defective check valve will sound like an underhood exhaust leak. Because the check valve is allowing the passage of exhaust gases through the system, the moisture and corrosiveness of these gases will eat through the check valve and air manifold, resulting in an exhaust leak. Another sign of a defective check valve is an air pump failure. If the check valve is stuck open, exhaust gases will be allowed to enter the air pump, and the result is a locked-up pump. Quite often, an air injection reactor tube or manifold will be directly attached to the check valve. This tube or manifold is the delivery path for air from the AIR pump to the exhaust system. A defective injection tube can also be recognized by an underhood exhaust leak noise. This problem may be caused by a check valve that is stuck closed, a failing diverter valve, or an air pump that is not supplying cool air to the tube. Both the check valve and the air pump should be tested whenever a leaking injection tube is found. Let's first look at inspecting and replacing the check valve. With a cool engine, visually inspect the check valve for damage due to rust and corrosion. Next, start the engine and listen for an exhaust leak coming from the check valve. If a leak is heard or damage is found, replace it. If no external damage or leaks are present, disconnect the pump outlet hose from the inlet side of the check valve. Connect a clean piece of heater hose to the inlet side of the check valve and blow through it. Air should pass freely through the valve. If not, the check valve is plugged and should be replaced. The next step for testing is to see if air will pass through it from the other direction, so removal of the valve will be necessary. To loosen rust and corrosion where the valve attaches to the injection tube, apply a liberal amount of penetrating oil onto the connection. For best results, allow at least 1 hour for the penetrating oil to soak in. Using 2 wrenches, one as a backup, loosen and remove the check valve from the air injection tube. Use caution so you do not bend or twist the injection tube. With the valve removed, blow air through it from the injection tube side. You may need a short piece of pipe in order to connect a piece of hose to it. Because it is a one-way valve, no air should pass through it from this direction. If air does pass through, the valve is defective and should be replaced. If that is the case, we recommend you also check the air pump for proper operation. Before reinstalling the valve or installing a new valve, coat any threads with anti-seize compound. Thread it onto the air tube by hand to prevent cross-threading, and tighten it using the 2-wrench method. It is important to support the injection tube to prevent damage during tightening. Lastly, reconnect the output hose to the check valve and tighten any clamps appropriately. Start the engine and check for exhaust leaks. We'll next look at inspecting and replacing the air injection tube. Most air injection tubes fail due to rust and corrosion, eventually creating an exhaust leak. With the engine running and the hood open, listen for an exhaust leak coming from the injection tube. If one is heard, inspect it for rusty areas that may be creating the leak. If found, replace the entire tube assembly. Remember, when touching any component under the hood, make sure to allow time for the engine to cool down. The air tube is attached to the exhaust manifold and therefore will be very hot if the engine has been run recently. In most cases, the fittings on the air tube will be very corroded and difficult to break loose. Before starting, apply a liberal amount of penetrating oil to the fittings. For best results, allow at least 1 hour for the penetrating oil to work in. To prevent skin knuckles and rounding off the hex nuts, use flare nut wrenches to loosen all fittings on the exhaust manifolds. Remove or disconnect the hose or fitting from the check valve. and remove the entire assembly from the engine. Match the old tube to the new one to be sure of proper replacement. Apply anti-seize compound to the threads of any fittings on the new tube. Install the new tube onto the engine, tightening all connections finger tight only. Once all connections have been started and are finger tight, finish tightening them with a flare nut wrench. Apply anti-seize compound to the threads of the check valve and reinstall the check valve on the manifold. Make sure to use the 2-wrench method when tightening. Reattach the air supply hose. Start the engine and listen for exhaust leaks. Whenever replacing the injection tube, we suggest installing a new air pump check valve. Remember, removal of the AIR system or failure to repair and maintain it will not only create an embarrassing situation at the emissions inspection station, you're also not doing any favors for the preservation of our environment.
Now let's quickly recap AIR manifold and check valve servicing. The most common sign of an AIR pump manifold or check valve failure is an exhaust leak coming from under the hood. The first step is to perform a visual inspection. Look for signs of rust and corrosion damage to the injection tubes and check valve. If damage is noticed, replace the necessary parts. To test a check valve, remove the air supply hose from it and using a clean piece of heater hose, try to blow through it. Air should flow freely in this direction. Remove it from the vehicle and attempt blowing through the opposite end of the valve. Air should not be able to pass through it from this direction. If it does, the valve is defective and should be replaced. When replacing an AIR pump check valve, coat the threads of the new one with anti-seize compound. Install the valve and tighten it securely. Reconnect the hose and you're done. Now let's review AIR manifold replacement. Once again, begin with a cool engine. Spray a rust penetrating oil on the threads of the fittings. Allow the penetrant to soak in for at least 1 hour. With the correct size flare nut wrench, loosen and disconnect the tube fittings. Disconnect the hose or fitting from the check valve and remove the manifold from the engine. Compare the new and old manifolds to be sure of proper fit. Apply anti-seize compound to the threads of the fittings on the new manifold. Start all of the fittings in the threads by hand. Once all of them have been started, tighten them securely using a flare nut wrench. Coat the threads of the check valve with anti-seize compound and reinstall it onto the manifold. Tighten it using the 2-wrench method. Reattach the AIR injection hose to the check valve. Start the engine and listen for leaks.
A common engine performance control used on today's vehicles is a ported vacuum switch, PVS, or thermal vacuum switch, often referred to as TVS. Ported vacuum or thermal vacuum switches are located in the vehicle's cooling system and can commonly be found in the radiator, the intake manifold, or on the thermostat housing. Their duty is to supply or block vacuum to a certain component as the engine coolant reaches a preset temperature. Thermal vacuum switches have been used on vehicles since the early 60s to control items like distributor vacuum advances, the EGR system, heated air intake systems, and canister purge operation, just to name a few. Symptoms of a failing thermal vacuum switch can include poor performance or economy, surging while highway driving, engine knock or detonation, rough idle, and a stumble or hesitation on acceleration. The first step for testing a thermal vacuum switch is to perform a visual inspection. Look for cracked or broken vacuum ports, which often happen because the plastic upper body portion of the switch has become brittle. This is caused by the continuous hot and cold cycling experienced during normal engine operation. Testing a thermal vacuum switch can be performed on